Hi there, it's Wim from Model Maker Systems. Today we look at how to prepare a CAD layout that we can create a cadastral plan from it. General plan, working plan, or a diagram. We start and create a new Survey Maker project. Go to the project, create new project to get the project screen. Title, Training to Clean CAD. Job code 0001. District and location, Centurion and Highveld. Make sure your datum settings are correct. Project file name I changed to CAD Clean. This is the name of the file on your hard drive. We can set the location of your projects. For now I use the default folder of Survey Maker projects. I create a subfolder CAD Cleaning. The rest of the project information you can fill in as you require them. Select OK to create the project. That's it. Now we have a clean project with no CAD or survey data. All the CAD and survey points we are going to create now gets automatically saved in our project folder. Currently under active dataset, no name. We start by loading in a CAD file. One of the ways would be from Windows Explorer, and I browse to my KCD file, then drag and drop the file on Survey Maker. Release the mouse button and confirm you want to import the file. The drag and drop will work for all Survey Maker file types like MMS and MMB as well. Alternatively, you can click on the project menu and choose Import CAD. When you get a CAD file with a lot of extra information on it, use the ID Elements, ID All Elements, and CAD Layer filter. Select the layers you do not want. In this case, the extra layer. With ID Elements, delete them. This illustration is only a simple layout and you will apply the same principles on a more complex plan. The first step will be to go to Calculations, Cadastral, and use the parallel check for CAD lines. For now, I will just display the layer after Erven and roads. To use this function, make sure you are in the free snap mode. Click on the input block of the first line parameter, select the first line and select the second line. The program automatically adds the coordinates for those lines. It shows me that the line is not parallel. I enter the width that I want the road to be, 10 meters. The auto tick will automatically add the closest rounded width. If the calculate lines to parallel is off, it will only do a check. If it's on, it will recalculate the second line you selected to be parallel to the first. You can select to have the pen settings or layer name changed, or do both for the checked and recalculated line once the check is done. It will help to visually keep track of the lines already tested by the function. The check button will execute the command. Repeat these steps for all the roads. Use the cross at the right top to close the function. To change the pen color to the original, I hold down the Shift key while I click Release on the top left of the area I want to select. While holding down the Shift, I move my cursor to the bottom right, and then without clicking, I release the Shift key. The selection area will be the selected rectangle. I select regular lines only. Go to ID Elements, Manipulate Selection, and change all to my pen number 15. Right-click to refresh the ID. If I zoom into one of the lines that's not parallel, you will see the lines are not snapped onto each other anymore. To fix the CAD lines, which aren't exactly snapping onto the intersection and corners, use the function Tools, CAD Housekeeping. The CAD Housekeeping function will neatly trim and extend the lines to meet within the radius specified. 0.5 meters should clean up most of the connections. If I zoom into the same corner as before, you will see that it is now fixed. To illustrate the Splay function, I will check existing and add splays where I still need to. Calculations, Cadastral, Splay Calculations. Tick on Only do CAD lines based input. We only want to do the CAD part and no points. Put in the splay distance you want to use. Put your cursor in the direction block and start by selecting the first line and then the second line. Select Calculate to add the splay line. The splay function will add, trim and meet the lines to the new splay distance. Delete the old line. Repeat this for all the splays you want to check or add. Close the window on the top right. Next we calculate points on all the Erven figure positions to see if there are any duplicates created. I use this as a check to make sure the CAD is clean. We ID all the CAD lines the same as before by holding down the Shift key and click and release. Move the cursor to the opposite corner and release the Shift key. Select all the regular lines. Next, go to ID Elements, Manipulate Selection. Generate points on ID CAD lines. Start with 1 for the naming options. Select both line endpoints and line intersections. This function will add points on all the endpoints or intersections or both for the ID'd CAD lines. Now check for duplication of points. That will indicate if our CAD layout is correct and all the lines snap onto each other. Go to Printouts, Report Type, Coordinate Comparison. Make the tolerance 200 mm on the upper limit and use the Only Print Duplicate Points. Select Show Comparison Printout to open the printout. Point 106 and 107 are close to each other. If you get any duplicates, you need to correct them by deleting one of the points and fixing the CAD. Now to quickly find the point, use the function Go to DTM. Add the point code, select Go to, and the cursor will be placed over the point, in this case below the pop-up. Zoom in and correct the CAD. Delete the line and one of the points. Use Move Line Endpoint with the DTM Snap mode to move the line to the point. Do a check again with the printout, and there should be no duplications of points. We only use this function as a check. Our CAD is clean, so ID all the DTM points and delete them. Select only the points. ID elements, delete. Next I change my outside lines to a CAD layer called Main Figure. Press delete while holding your cursor next to a line to get the existing line properties. Change the layer name to Main Figure. and the line color to yellow. Change the thickness to 0.35 mm. Now use the CAD line edit shortcut to edit the outside boundary to those properties. Once the work is on separate layers, toggle the display to turn the different layers on or off. If I turn off the display of the main figure, you can see it turns off on the CAD screen. You want to have all the different elements on their own layers. Next, I add some important points before we add all our points. Go to Point, Add on the left menu. Change the snap mode to intersection. Select the first main figure position and change the code to M1. And my cadastral code is M for the main figure. Use the increment numerical and suffix. Use the quick button and complete all the main figure points. Turn on the codes and you should see the cadastral M1 to M4 codes. I will repeat these steps to add points on my block corners. The first code will be A1 and the cadastral code B for block corner. Add all the rest of the points. Block 2 will start with B1. Block 3 will start with C1. We have a servitude, so I turn on that CAD layer. On the servitude line, I add points S1 and S2. I'm finished with the servitude points, so I turn the layer off to eliminate extra points where the servitude line crosses the Erf lines. Next, we calculate points on all the remaining Erven figure corners. We ID all the CAD lines the same as before by holding down the Shift key. Move the cursor to the opposite corner and release the Shift key. Select the regular lines. Next, go to ID Elements, Manipulate Selection, Generate Points on ID CAD lines. Select both line endpoints and line intersection. Start with 1 for the naming options. The function will only add points on the endpoints and intersection of all the Erven figures where there are no points yet. Watch the video on Add Points for fieldwork line running for more information on how to add points that they are more sequential for setting out work. We now have a completed coordinate layout that we can do the cadastral plans from, and we know that there are no duplicate points. At this stage, we could have imported a survey file, or you could have worked on an existing survey and want to overlay those points. In this exercise, we calculated the points from our CAD layout, just to show you that the file has no duplicates. If you did bring in some points separate and you did not add them on the CAD as we did, you can check if the points are online using the beacon alignment tool. This training file has a bend at point 80, making M1 to M2 not a straight line, so all the points are offline. Go to Calculations, General, Beacon Alignment. Put your cursor on the point name field and select the first and last DTM point on a line segment using the DTM snap mode. Then select the points M1 to M2 to check. You can check all the points on a segment if you use the Specify a Radius to Use option. This option will report all the points on the segment within the radius area, 0.5 meter radius. Search for coordinates creates a report. This report shows that all the points are offline. I changed the pen color to be different. The tick for recalculate points online and follow CAD lines are selected. Calculate to execute the command. If I run the command again, notice all the points are now online and the CAD lines and points moved online. I will change the green line back to the main figure color. Because the line with the bend was two separate lines for this illustration, I will now make it only one line. If you brought in your DTM from a file or calculations, the beacon alignment tool is a check you can use before you start drawing your CAD to the DTM. The line of the Erf and the survey point are now online between M1 and M2. We are at the second to last step, and it's time to add our Erf numbers to the Erfs. First, we set up our layer information. Layer name, Erf number. Color brown, size 3,5 by 1.57. Use the function shortcut generate Erf numbers following a line path. It will ask me the start from number. Free snap mode. Click inside the Erf without a number and end in the first figure that needs a number. If you get to a single Erf, just click twice in the same Erf. As you can see, this function makes light work of placing Erf numbers. It's important not to go across roads or footpaths. The program will recognize it as an Erf and add the Erf number in the center of that area. For the road, I copy one of the existing numbers and then edit it to the Erf number I want for the road. In the final step, I will illustrate how to add surrounding data using the Offshoot line function. I turn my DTM codes on. Activate the line Offshoot function. Then I select point M4, which will be the starting point for my line. DTM snap mode. If you want the program to start drawing the line a certain distance away from the point, use the distance and direction below the coordinates. In this case, we want the line drawn starting from the point going 10 meters in the same direction as C1 to M4. When in the direction input, type equals C1, M4. Press the enter key, which tells the program to do a join calculation between the two specified points. Draw line will generate the line with those inputs and on the active layer. I turn my surrounding data layer on. Then I hold my cursor close to a surrounding line and press delete. This gets the properties and I edit the line to have the same properties. Okay, this is the final product. We have some surrounding text and lines, and just to demonstrate how the CAD layers work, go to the display on top to view the current layers. You can toggle the display of any layer on or off as you need it while you work. Make changes if the layers are not correct. At this stage we have a draft working plan on the main screen. For this working plan we can go and create all the cadastral plans that we need. The video on how to create the Erven file picks up where we end here and explains all you need to know about creating Erven files. That's it for this video. Please make sure to like and subscribe, and remember to hit the bell icon to get notified as soon as we upload new content.